From the beautiful studios of Way Happy, this is Mr. Meyer, and we are doing 12-4 geometric sequences. So just like 12-3, where we got to see that there was a formula for when they were adding something, a geometric sequence is when they multiply by the same number every time. So if somebody's going to multiply by the same number every time, that's going to be called a geometric sequence. Now look, that could be dividing, which means you are multiplying by a fraction. And whatever they are multiplying by, that's what's called the common ratio, also going to be known as R in our case. R is our common ratio. Geometric means what number is right in between two numbers. And a geometric series is summing up a bunch of numbers that have a common ratio. And that will be a formula too. So let's start off with our general rule. So here's how you find explicit formula. Explicit formula highlighted right there. AN is the first term times R. Oops, I forgot, to the n minus 1 power. So make sure you get that in there. So R to the n minus 1 power, that is your explicit form. And R is your common ratio. And if you want recursive, you have to tell me what A1 equals, and then you can tell me what AN is. It's the term in front of it times R. And while we're on that form of formulas again, let's go ahead and throw this at you too, that the sum of a finite geometric series is just A1 times 1 minus R to the n over 1 minus R. So let's go ahead and figure this out. Let us determine whether the sequence is geometric or arithmetic, and then find what D or R is in this case. So looking at that first one, it looks like they subtracted 7. And if I subtract 7 again, so just like the old days, this one is called arithmetic. And I know that there has a common difference, which I will call -7. Now do the same thing for number 2. I will subtract them, and if I subtract, I get -90. And then I subtract is -30, and I say, oh, darn it, that's not arithmetic. Well, what about geometric? And the way you find out geometric is you just divide. You do 90 over 180, and that's a half. And then I do 60 over 90, and that is 2/3. And I notice that those aren't the same, so it is also not geometric. So it is neither. And then last but not least, number 3. Let's find out if it's arithmetic. It looks like they subtracted 4. And subtracted 4 again, no, looks like they subtracted, what, 0.8? So it's definitely not arithmetic. So if I check now for geometric, I do 1 over 5, which is 0.2. And then I do 0.2 over 1, which is 0.2. Oh, this is looking a lot more promising. And then I see 0.04 over 0.2, which is 0.2. And I say, there you go. This one is geometric. And if it's geometric, I can find R, which we just did, and it is 0.2. And so there is my geometric sequence. Let's go down and look at this one. Find the 7th term of a geometric sequence. Good news, they're telling me it's geometric. So I can use the formulas AN equals A1R to the n minus 1 power. If I plug that in, that means I can find the 7th term when I know the first term is, and now I need to just figure out what the heck R is. Well, R is what they're multiplying by, so again, I'll do 12 over 3, which is 4. Or you could have done 48 over 12, which is 4. Or 192 over 48. Whatever it is, you could just divide with the term behind it by the one in front of it. You know it's 4, and so now I just got to figure out what 3 times 4 to the 6th is. So I guess I could grab a calculator. And I can type in 3 times 4 to the 6th, or 3 times 4 to the 6th, and get 12288 and feel pretty darn good. 12288 and jump up and down. That is what the 7th term of the sequence is. And we could try another one. I don't know what I had here. Probably A2 and A4. Or something like that. So let's see. If I wanted to find the 8th term of this one, then all I have to do is, all right, I'm going to pretend, I know this sequence goes like this. It has something, right? and then 36, and then something, and then 324. And so all I want to do is I'm going to rewrite this for a brief second. I'm going to call this A1 and this A3. And the reason I do that is so I can use our usual formula. Because I can say 324 is 36 times r to the 3 minus 1 power. Now maybe pause it for a second and look. I knew the third term was 324, that's why it ends at 3. And so then I can put 324 on the left. And then when I can do that, I know the first term is 36. Now, this isn't true because 36 is the first term, but I've kind of made my own partial sum here, my partial sequence, where I ignored that for a brief second. Well, here we go. We get 324 equals 36r squared. So now I can divide by 36. And then I get 9. So r squared is 9. So that means r must be, now again, we're drawing in the square root, so plus or minus 3. We put the square root in there. It was never there to begin with. We put it in to solve it. If it was already there, then you'd just go with whatever sign it is. But since we put it in, it is positive or negative. And that now tells me that r is plus or minus 3. And now I can actually answer the question. Because you can see they're multiplying by 3. That means we could divide by 3 to actually find A1. Remember I did that. Well, now I can tell you that A1 is probably 12 or negative 12. Then this is 36. Then this is who knows what. And then this is 324. And then I want to get all the way out. So what do? I go the 8th term is equal to the first term, which we said is plus or minus 12. So it's kind of confusing. I'm going to have to do it twice is all that means. Then times plus or minus 3 to the 8 minus 1 power. So let's call that the 7. And so now we know that 3 to the 7th and times 12, I can grab my calculator and say 12 times 3 to the 7th is 26244, or the negative of that version, plus or minus 26244. Because think of all the combinations. It's going to be a plus 12 and a negative powered one, or a positive and a positive, or a negative and a positive, or a negative and a negative. And no matter what, you will only get those two combinations. So I don't know which one it is. If you gave me some more numbers in the list, I could tell you which one it is, but that's as far as I can go right now. All right, let's take a break, and I will then come back with some more. All righty, nice work. Now let's talk about the word geometric mean. Geometric mean just tells you that there are blanks between the two numbers that they give you. So there are, in this case, just one number between 4/9 and 2536. So all I need to know is, what is that number? And they're multiplying by something, and they're getting this number, and then they're multiplying by something to get that. So what is that they're multiplying by, so we can fill it in? And again, there's a shortcut, but I'm not going to use it because I want you to use the sequence, this formula that says this is A1, this is A2, and this is A3. And then just like the one we did 2 seconds ago, I'm going to set it up. I'm going to say 2536 is equal to the first term times r to the n minus 1 power. Oops, I knew what n was. N is a 3. So I now can say, multiply, I can move that 4/9 to the other side. So I have 2536, and I'm going to multiply that by 9/4. And I get 1.56, and if you're like me, you want to know what that is in fraction form. So that's 25/16. And if I know it's 25/16, I now have 25/16 equals r squared. And if I square root both of those, then I know that r is plus or minus 5/4. So they are multiplying by 5/4, but that's our r value. So now I have to take 4/9 and I have to multiply it by 5/4. Remember, plus or minus, 4s would cancel, and we'd get 5/9. And so that's the missing number. I don't know if it's positive or negative because of the fact that I don't know if r is positive or negative. There's not enough information to tell me that r is negative or positive for that matter. All right, what about this last couple groups here? Using a series formula. So the series formula, again, a very simple formula, which we like. And so let's see if we can figure out how we have to do this. So the sum formula of any number is a1, 1 minus r to the n over 1 minus r. Oops, I almost put plus. And notice that that formula has nothing to do with the last number in the list, so you only need the first number in the list and what are they multiplying by. And if you tell me it's geometric, I already know they're multiplying by something. I can look at the list and say, hey, they're multiplying by 2. So first number, 1, and then 1 minus 2 to the 8th, all over 1 minus 2. So let's see what 1 minus 2 to the 8th, what's 2 to the 8th? 2, 4, 8, 16, 32, 64, 128, 256. So 1 minus 256 all over negative 1. So that negative 255 all over negative 1, which is 255. So if you add up this list, you get 255. All right, look at number 8. Sometimes I don't know the first term, or do I, right? They tell me to plug a 1 in. So if I plug a 1 in, that would build this list right here. If I plug a 1 in, I'd have a half to the 0, which is 1. Then if I plug in a 2 in, I'd have a half to the 1. If I plug a 3 in, I would have a half squared, and so on, and so on. Now they want us to sum up the first 6 terms. Going from 1 to 6 is 6 terms. So that means the sum of the first 6 is the first term. And what are they multiplying by every time right there? Looks like a half. 1 minus a half to the 6th, all over 1 minus a half. So again, 1 minus 2, 4, 8, 16, 32, 64. So that is 1 minus 1/64 all over negative a half. Oops, I'm sorry, positive a half. That is the ugliest looking half ever. And now I can just change that to 64/64. And I have 63 over 64 over 1/2. So if I do complex fraction, copy the top, change it to dot, and flip the denominator. Half of 64, 32. So I have 63 30-seconds as my final answer. All right, let's give you one, a summation, and then we'll do a word problem and we'll be out of here. All right, nice work again. Now, last but not least, let's talk about an online tournament that starts with 1,024 players. So at the start, we have 1,024 players. Then at the end of round one, they've all played, and 4 of them play and only 1 moves on. So out of all of that, if you divide 1,024, you get 256 players after you multiplied it by 1/4. At the end of round 2 then, 4 players, and again, it was 4 players in a game, if you're wondering why I was dividing by 4. You divide by 4 to only have 1 come out, then there would be only 64 players left. And then divide by 4 and divide by 4, and we can figure out how many rounds this tournament will last. However, the question is how many games must be played. So be a little careful. So here we go. The rounds. You know what? I'm going to call this when n is 1 and this is n is 2 because I want it to match up with what round it is. So I don't care that there was 1,024 to start. So here's my formula. I'm going to say we started with 256. They get cut into a quarter every n minus 1. Now when does that 256 people equal 1? I want to solve that. So I get 1 over 256 equals 1/4 to the n minus 1 power. Great time to log both sides. Log of 1 over 256 equals log of 1 over 4 to the n minus 1, because why? I can bring the n minus 1 down and divide it. So I have log, I'll show my work here, of 256, which I'm going to do on my calculator, equals n minus 1 times the log of 1/4. Now I can divide the log of 1/4 over, and then I'll just have to add 1. So grab my calculator and say, all right, what is the log of 1 over 256 divided by the log of 1 over 4. Calculator says 4, and then we're going to add 1, so n is a 5. So they will play 5 rounds until they get down to 1 player. Now, that's cool to know. It ends in round 5. But I want to know how many games they played. Well, that's not a big deal either, right? To figure out how many games they played, all I got to do is sum this up. So I will do the sum of the first 5 rounds is the first term, 1 minus r to the n, over 1 minus r. So I got first term, 256, times 1 minus 1/4 to the 5th, all over 1 minus 1/4. So that looks to me like, yuck, 256, 1 minus 0.25 to the 5th, all of that over 0.75, and I get 341. So that means they play 341 games total. So that's how many games they would play, and if you add that up, you're good. End of story. Have a great day. Stay happy, and I'll see you tomorrow.